Hello and welcome back to Masculine Learning and Mask TV. We are here again to help you, and today grade 9s we are going to focus on geometry of a straight line. Please sit and have everything that you need: your pen, your book, your pencil, your ruler and your eraser. Please make sure that you ask all the possible questions that you really need to ask, so that at the end of this session you are able to understand angles and relationships of any straight line that is given to you. Also explore the lines that we call perpendicular, the lines that are intersecting, as well as the lines that are parallel. And you then need to know how to use all this information to respond to the questions that is given to you during your examination and any task. Please join us and let's go and do this together. Okay, so we're going to start with perpendicular lines. So perpendicular lines are basically just the lines that if ever you had two lines that are drawn in this manner, so any line set up that is drawn in this case, if I say I have line AB, which is this line, and I said I have CD, which is my horizontal line. So you see my vertical line and my horizontal line, all the time where they meet, we call it 90 degrees, and that is perpendicular. This can be found anywhere, even in your book. So if you look at this book, the corner of the book there is literally 90 degrees as well. So which means that this vertical line is perpendicular to the horizontal line. So that's how we determine the perpendicular line. We have brought you some little examples of how perpendicular lines look like. So you can see here we have the sign on the road, which shows that we have this line and that line, which looks exactly as what I showed you on my left. This is perpendicular. But if you check, there is other road that you can find with this particular sign. Please don't mistake it and say Maski TV said that when you have a road sign like this, it's always perpendicular. Some of them are not, so this is not perpendicular. It doesn't matter that there's a T-junction, but this is not the T-junction of a perpendicular, simply because the angles that are created here, they are not 90 degrees. You can see. So here our angles are all 90 degrees, and that's what makes it perpendicular. We can always find that in any road or form. So we have just given you an example of a road there that shows T-junction, which is actually perpendicular as you go into it, right? So as we are learning about that, we would have to show you everything that has to do. So that is an example of perpendicular lines as I've drawn there. So every time you have a perpendicular or line that is drawn vertically and then joined with the one that is horizontally, they will always form 90 degrees. And that is what we call perpendicular. There's a sign that we use, or a symbol that we use like this, which is literally just indicating our horizontal and the vertical line. We call that a perpendicular symbol. And in these diagrams that we have, you can see that we have told you that for triangle, for this lines AB and the line CD, we are telling you that the angle B, which B are we talking about, particularly this, is going to be 90 degrees, or it is given to be 90 degrees. So A, angle BD, it's 90 degrees, as well as A, angle BC. So even this side as well is going to be 90 degrees, reason being that the sum of the angles on any straight line will always give us 180 degrees. When I show you how is that possible, so if I have a line, like a straight line like this one, and I just go there and I put my protractor there, you can see that it starts from 0, and when I reach the end, it gives me 180 degrees. So that is how we are saying that every line or angles that are on the line of a straight line, when you add them together, they're always going to give us 180 degrees. Okay, so same applies to these lines. Even though they don't look like they're straight, they are literally straight. So straight line HG right? This is my straight line, and also I have a straight line EF. Right, so those are the straight lines we are talking about. Every time you have those straight lines, you just have to remember that they have angles that is 90 degrees. So in this case, our angle there, which is E, angle OH, this angle there, it's 90 degrees. As soon as I know that that is 90 degrees, because of the straight line information we just spoke about, also the angle that is here will be 90 degrees, and that angle is H, angle OF. So the way of representing the angle differs, or is more than one. So this is one way of representing our angles, like A, B, D. But I can also write it as angle, then I say A, B, D. So in this case, I'm still saying the same thing. For as long as my B is in between, that is my reference angle that I'm talking about. So please bear in mind and take note that if you see it with this something that looks like a less than, and as well as if I have a small hat at the top like this, I am still representing their angles. This is one way or two ways that we have. Another one can be when they then write numbers into it. So we can come here and we just write small number 1 and then small number 2. So if you have those numbers like are written like that, you can always and write that as an angle, and you say I have angle B1, right? You can say I have angle B1. So you are allowed to write it, but with the head there. So this one represents that an angle, instead of us writing it as A, angle BD, we then just write it as B1. Did you get that? I'm very sure that you guys have mastered and understand this part as well, right? So please make sure that you always just write it the way it makes sense to you and the way you are comfortable. But make sure that if the diagram is given to you without the 1 and the 2, you don't just impose, you put them in your head alone without showing it. So if they didn't give you the 1 and 2, just like in our diagrams here, if you want to use 1 and 2, then it means when you give us the answer, you'll have to redraw the diagram and then you put the 1 and 2. Don't just go and use this scenario if it's not given or you are not willing to redraw the graph. Okay, so that is the important part of it, right? Angles, point of or lines of intersections that have angles around it. So this is one of the examples. So look at it. Whenever you have two lines or many that are joining each other at some point, those lines will then meet, and at that point that you are having there, like this one, at that point of intersection of the two lines, not everyone. So if you check, this one is similar to this which we had here, if you check it properly. So you can see that this we're also intersecting here. Let me show you. They are also intersecting here, right? You see that point. So that will simply means that the angle that I find here, which is E angle OH, will also be equal to the angle that I'll find here, which will be G angle OF, right? So that is the vertical opposite angles that is made out of the intersecting line. So their properties, as I said, they will have something we call vertical opposite angles. Since these two angles are opposite to one another like that, so we call them vertical opposite angle, and that will simply means that angle O2, right, will then be equal to angle O4. So that is how you will write it down, right? For as long as you have a straight line, please understand that it does not happen to every line, but the lines have to be a continuous straight line like that, and then they intersect like we are having them in this moment here, right? Also, angle O1 will then be equal to angle O3. That is vertical opposite angles. So if you are writing this in response to a particular question, you need to always write the reason. Don't just write these angles are equal and then you move on. You say the angles are equal and then you do say this is vertical opposite angles. So in summary, this is how we write vertical opposite angles. We say vert op L and the slash S, right? So that is vertical opposite angles, and that is how you write it, right? We have talked about the sum of the angles being 180. We have talked about vertical opposite angles. What does this mean in here? That will simply just means that you just say O1 plus O2, for example, and here is when you are using line CD. So if we use line CD in this one, if we use line CD, then O1, which is the angle here, plus the angle O2 must give us 180 degrees, and that is because of the angles on a straight line. So if you focus on each and every line, you'll be able to see that. Okay, so here let's just put this properly. So we're saying vertical opposite angles. So the angle, remember, we write it as that. So that is the sign that we use for our angles, as I have shown it to you previously, that we can use that to represent the angle as well. We can either use a hat or we can use the side angle sign, which is the one we have here. Okay, so if this is what you can do, for which you have, like, let's say we are talking about the line DCCD, as we have said, then O1 and plus O2 will give us 180 degrees. But if I was talking about line AB, and that will be a different scenario. For line AB, I will then have a different set of answers, right? So that will be O2 will then be plus O3 will be equals to 180 degrees, also because we have sum of the angles of a triangle. So you can see that this top part here will be, we can see that the part here will be the 180 degrees, but as well as the one at the bottom will also be 180 degrees across the same line. So if you look at that, and you'll be able to say, oh, okay, in normal sense, this will be added to 380 degrees, which is the angles around the point. So this is what you need to know and how to understand. As we have just indicated, that whenever you have the intersection, this particular point here can help us to get the vertical opposite angles, which are equal, right? So that's where you have your straight line. So these intersections also help us to get all the angles that are equal, but that happens if we have a transversal line that is drawn again on other lines. So here, when we have two or more lines, then we would have something we call transversal line. An intersection will help us with the angles. All right. Okay. So as we are looking at this type of angle, so we have spoken about perpendicular, we have spoken about intersections, right? So the last part of lines that we haven't yet touched to is the parallel lines. So parallel lines always work with a particular line called a transversal line, which I just have shown you. So in the parallel lines, we have particular types of angles that are equal, and only one that is supplementary. So we'll talk about them. So we have the angles that is corresponding angles, we have alternating angles, and we have co-interior angles. I just put this to show you that we do use this information even in real life situation. So that is where you can see that if you look at what I've highlighted there, it does show that my line that is going this way, it's actually parallel to this line as well as that one. If you look at that line properly, because the definition of parallel lines is that parallel lines have an equal distance in between them, right? So the distance here will be the same. If this line is parallel to that line and also that line, this distance in between here is supposed to be the same all over until the end. So that will happen also for this one. Its distance there was going to be equal until the end, and hence we call them parallel lines, which they will have particular angles that are equal, as we have indicated. Okay. Now this is the description of the angles that we are talking about. So we do have angles that we say they are alternating from there. So alternating angles, simple means when you have something like this, I usually just call it a Z, but if you have a straight line like that in this format, let's draw them here so you can see. If you have a straight line like this, and then another straight line like that, and then they come a transversal line like this, right? And then they come a transversal line like that, and then I'm given points, or perhaps I'm given angles. Let's say I'm told that this angle here, it's X. And then here I was told this is angle F. Y, for example, right? So if I was given that, what I would do then is to trace. You guys know how to trace? Is to trace. So you need to trace your side as we do here. So look at this. I'm going this way up until my transversal line. I go down and I go this way, right? The moment I see that, I should be able to say I have alternating angles, just like that. But for me to say that the alternating angles are equal, I need to have parallel lines. So if the lines are not said to be parallel, I cannot just conclude that they are parallel. I have to see this into my lines. This line is very important because it represents parallel. So I need to see this small line like that. And if suppose this was given to be like line AB and this was given to be line CD, I will then be able to say angle X is equals to angle Y, and then my reason will be alternating angles, right? Alternating angles are equal like that. But then why am I saying they're equal? Because I have my line, or my line AB parallel to my line CD. So this is how you would have to say it. You say X equals Y, and you do tell them that this is the reason is because there's alternating angles which are equal, but they cannot alternate and be equal if I don't have parallel lines. So therefore you need to name the sides of the parallel lines that are given to you. So that's what is very, very important. Please take note and always just do as I'm trying to guide right now. Okay. So similar will happen. It doesn't matter which side is I'm going from, but I need to have my Z. Or it can be looking upside down, or look like an N, or like this one which we have here. But if you trace it, you will see it's still a Z. And because I'm given parallel lines, then these two angles are equal. Okay, so that is one. Then when we talk about corresponding angles that are equal as well, we're going to use a similar scenario. So if I have a straight lines, two of them like this, and then I have my transversal line. So let's put our transversal line there. And then I have angles that I usually call them to be underarms angle, because it's the only thing that can give me something like this. It's literally underarm. So I have underarms angles. So in the underarms angle, you can see if I have an angle there and I have another angle here, I will say that those two angles are corresponding. But for me to end up saying that corresponding angles are equal, what must I do? Remember, we must put the sign that shows that the corresponding angles are equal. Then you can go and then you trace what needs to be done to say, okay, I said my corresponding angles are equal, so let me see if I can find my underarms, which does look like an F. Do you see? So I did find my underarms there, and another one is here, which is looking like F. Therefore, corresponding angles will be equal. And this is the idea that has been used in all of these shapes that we have here. All right. So this is another one of vertical opposite angle, which we have already done. So this one, we're not going to dwell on it because we have already done this. You just need to remember that as long as you have a straight line, then that means it is a vertical opposite angles that are equal, right? So the sum of the angles, the one for co-interior angle. In this case, a co-interior angle, if we have two lines, let me draw them for you. If we have two lines like this, as well, and then I have my transversal line like that, and I'm given that this is parallel lines. That is the only time I can say they are equal, remember, is if I'm given parallel lines. And then there's an angle inside, like the angle A we had there and the angle B we are having here. These two angles, when we add them together, they must give us 180 degrees. Hence, we are saying they are supplementary, right? They are co-interior angle. So these two angles must give us 180 degrees when we add them together. They are not equal. But for me to trace, I always look for a U. It doesn't matter how this U look like, but I have to find a U, and my angles must be inside that U. And that's where I decide to say that this is a co-interior angle. And that is what you do. Okay, so here I just show you some example of how you deal with this question. So for example here, they say solve whether this line is parallel or not, right? So if you look at it, you will give a reason. Since we said we have to trace, so let's see. If I'm here, for example, to start with, we are not given parallel lines. So you can assume the only way you go will be to find the angles. So if I draw my tracing there, and I go this way, this look like my Z, but can you see that this is 106 and this is 108 degrees? So that means that my angles are not equal, which means that these alternating angles which are not equal cannot give me parallel lines. So therefore, this AB is not parallel to CD. So that's how you describe or you explain if it's parallel or it is not. There's a lot of questions that you can find in our spot on, and it is very important for you to have the spot on. It will help us to get to many questions and many answers. So this is the spot on I'm talking about, and it has quite a lot of these questions very nicely explained for us to get to the solution, like the one just I've shown on the chalkboard now. So you can see that it shows how the angle are found and how you get to it. So I'm going to do only one, and then the rest you can just take the screenshot and then you can go to it. So let's start with the example number 2. So in example number 2, we are given, let's start with the parallel lines that are given to us there. We are given the parallel lines, that is parallel line is PQ and then RS. Do you see those two lines are given to be parallel? So immediately you have those two lines, you can actually take them away from whatever thing that you have, take them away from the noise, and then you can be able to talk to them like that. Do we have that line? No, we don't. So the line that we have is not coming there, it's coming somewhere else. So let's do this. Our parallel lines, like that, and then we have the line that is going from this point to here, somewhere there, okay? So that is named to be, let's label them P, Q, R, S. That's what we have. Do you see? I've just taken it out for me to find this. But also, in all this which is drawn like that, we do have connections. So if I draw this, it goes back there, and there's another line that goes somewhere to my R there, and, right? But I'm given that this is parallel. So let's put our parallel lines, symbol, and also we have points. So we have to find the angles that we don't have. For example, we have to find the A, and we have to find B, and we have to find C and D, right? So to start, we would need to try and trace and see where we're going to get our parallel lines, having the co-interior, having the corresponding, having the alternating angles. So if I start here and I go this way to my 58, that's my transversal, and I go back. Did you see how I go to D? So that means that if this angle given to me is 58 degrees, that makes D also 58 degrees. So I'm just going to go there and say D equals 58 degrees. It doesn't matter which sign you can start with. You can literally start with anything as long as you understand what you are saying. But if I say D is it's equals to 58 degrees, the reason will be what? That is alternating angles, right? Alternating angles are equal. So that's why I'm saying that this is equal to that. Then I indicate my parallel lines. PQ is parallel to RS. Do you see how you get to the answers? So that is one of the way to do that. You can find your A as well by using the sum of the angles inside a triangle, or you can just find it by when you are done finding anything. So A, it's said to be equals to 180 minus the rest of the answers. But how is that possible? Because when I have A plus Q, which is 58 degrees, plus the angle, which is 80 degrees, which is P angle TQ. So in triangle, P, T, and Q. That's the triangle we are talking about. A plus 58 plus 80 must always be 180 degrees. And that's why we have this statement here, which says A equals to 180 degrees minus, and the bracket 80 plus 58, and the sum of angles in the triangle. So then that means our A, therefore, when you calculate it, will then be equals to 42 degrees. I just added this step for you to be able to relate how did this one come about, so that you know what happened for us to end up with this statement. So you start by just writing like that, pick up your triangle, and then after that you can find the solutions, right? So now we know we can actually label it. Our A is now 42 degrees. Our D we said is 58. And then now we can find our C. We can also find our B, right? So let's see how we're going to find the C in this case. We can actually use this transversal line to find the C, or we can use the sum of the angles of a straight line, right? So we have two options here. If we want to use this transversal line, we can trace back like this, and then we trace down and then back. So you see, our angle C will also be equals to 42 degrees, alternating angles. Okay, so that is how you're going to find that. As soon as you have your C, you have the 22, you can then use the similar method to find angle B, which is the sum of the angles inside the triangle. The rest of the questions, I am very sure that you guys can be able to get to them, and you can be able to then go to our spot on and get many of these questions, right? So if you look in the second one, it is a straightforward one, similar to what we have done. It does show that X there. For us to find X, we can use co-interior angle. Then X will be equals to 120, right? Also, to find Y, we can either use the angles on the straight line, or we can use the corresponding angles for us to get it as 60. So that is what you can do and how you can get to these questions properly, right? So that is the perfect way for us to get to the question. So there is a lot of questions that we can still find inside our spot on and any other books that we have, Platinum, our X kit and all that for us to look into this and answer the question properly. So if you look at this, you can take the screenshot, and then if you get stuck into answering this question, you can then ask our friend Masky. So you can see this one, embrace the angle around the point. The first question, embrace the angle around the point. The second question, embrace the idea of a perpendicular line, as well as the third question. Whenever you see 90, just remember that the embracement there will be of a perpendicular line. And the fourth one, embrace the angles on a straight line, and as well as the vertical opposite angles, and then as well as the angles around the point. So it embraces practically three things that we have already covered. While number two, embrace all type of angles that we have dealt with, alternating angles, corresponding angles, vertical opposite angles, and then that's how you're going to use this given diagram to respond to those particular questions. Today's lesson sounded very, very long or short. I'm not sure how you felt, but it did sounded very short. Either way, this is geometry, so this is how it is. The more you practice, the more you'll get to it. But if you get stuck, please ask our friend, our AI-empowered tool called Masky, that will help you to get to the right questions step by step. And if you don't remember the numbers, please save them. It's 072-091-0388. Masky will help you to get to the some questions, and it can help you step by step to do what you can't do by yourself. It is like your tutor, in addition to the books that you can shop online. From Teacher Tandy and Masky Miller Learning with Masky TV. I have enjoyed seeing you this afternoon. I hope you guys have enjoyed it as well, and you're going to use this continuously to learn more on the geometry of straight line. Until we see you next time. Bye.
And now we enter our next exciting chapter with the launch of Maskyverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.